Hello students. Now I am going to talk about sampling distribution in a module 5 in the subject complex analysis, probability and statistical methods. So it is a continuation of the sampling distribution. So in a previous presentation I given the more theory part about that sampling. It is a continuation part of that only. So now we'll see what is meant by error. While testing a hypothesis, we usually come across two types of error, that is type 1 and then type 2 error. What is meant by this type 1 error? If a null hypothesis is rejected while it should have been accepted, such a rejection of the true hypothesis is called as type 1 error and it is denoted by alpha, which is known as the level of significance. The probability of correct decision is thus in this case is alpha minus 1. Now we'll see about this type 2 error. If a null hypothesis is accepted while it should have been rejected, such an error of acceptance of the false hypothesis is called the type 2 error and is denoted by beta. The probability of correct decision in this case is 1 minus beta, which is known as the power of this test. So we can explain this one by taking this chart. You just observe students here. Hypothesis is true, hypothesis is false. Like that statement we are taken. And here how we can accept, how we can reject this null hypothesis means accept hypothesis, reject hypothesis. Now one by one you just see. If hypothesis is true, then we are going to accept the hypothesis. That is correct decision. Here we can't see any of the error. Now the second case is hypothesis is true even though we are rejecting the hypothesis. So that is what type 1 error. That only I explained in the previous slide. So now we'll see the next one. If hypothesis is false even though we are accepting that hypothesis, this is what type 2 error. If hypothesis is false means of course we are going to reject. This is correct decision. So here like this you just remember the type 1 error and also the type 2 error. Now we'll see the significance level. What is mean by the significance level means the probability level. Significance level means it is a probability level. So below which leads to the rejection of the hypothesis is known as significance level. This probability is conventionally fixed at 0.05 or 0.01. We can also tell this one as at 5% or 1% level of significance. These are called the significance levels. You just see here one particular number will be there for 5% and 1%. So within that, if our obtained value comes means then only we are going to accept, or else that is we are going to reject. So some particular values we are going to fix now, that value only we are going to call it as a significance level or probability level. We feel confident in rejecting a hypothesis at 1% level of significance than at 5% level of significance. 5% level of significance can also be understood as the probability of committing error of either type 1 or type 2 error is 0.05. So usually we will prefer that 1% level of significance only compared to 5% level of significance. Test of significance and confidence intervals. How to test that significance? How to test means hypothesis means. So further some procedure will be there. That one you have to remember. The process which helps us to decide whether we have to accept or reject the hypothesis is called as what? Test of significance. Let us suppose we have a normal population with mean mu and the standard deviation will be the sigma. If x bar is the sample mean and next n represents the sample size, then the quantity z is defined by like this. You have to remember this z. Z is nothing but it is a standard normal variate. How we can write this z means x bar minus mu divided by sigma divided by root n. From the table of normal areas, we can find 95% of the area line between z equals to minus 1.96 to z equals to 1.96. In other words, we can say that 95% confidence that z lies between these two regions, minus 1.96 and 1.96. Further, 5% level of significance is denoted by z 0.05. Here you have to remember one thing, students. 95% level of significance or 5% level of significance means you have to remember the number minus 1.96 and 1.96. Within that region only we are going to call it as that significance region. So except that means that is insignificant region. Similarly, for this 99% or 1% level of significance, we kept some other number. That number, how we got it means with the help of that normal table. So that number will be minus 2.58 and plus 2.58. That region only we are going to call it as a significance region. Except that means we are going to call that as an insignificant region. Here you just remember. So that 95% or 5% means the number is plus or minus 1.96. And that 99% or 1% means you have to remember 2.58 plus or minus, that you have to remember. So that one we can represent in the form of equation like this. So x bar minus 1.96 sigma divided by root n, which is less than or equals to mu less than or equals to x bar plus 1.96 into sigma divided by root n. Take this as equation number 1. Similarly, the next equation will be x bar minus 2.58 sigma by root n less than or equals to mu less than or equals to x bar plus 2.58 sigma divided by root n. Take this as equation number 2. Hence, we can say that equation 1 is the 95% confidence interval and equation 2 is the 99% confidence level. The same thing we can depict in the form of the graph. You just take that normal graph. Normal graph means it is a bell-shaped curve. You just see here the first one represents the 95% and the second one will be the 99%. The significant region is nothing but minus 1.96 to 1.96. It is a symmetrical curve. So here 2.5%, here 2.5% error is there and the rest of the region will be the 95%. And here also the same thing. It is also a symmetrical curve. So here 99% means the number you have to remember minus 2.58 and then plus 2.58. Within that region, that only we are going to call it as a significant region. Now, one-tailed and two-tailed test. So in our test of acceptance or non-acceptance of the hypothesis, we concentrate on the value of z. On both the sides, if you are going to concentrate means that we are going to call it as a two-tailed test. If you concentrate only one side of the curve, that normal curve means, then only we are going to call it as a one-tailed curve, one-tailed test. So that one we can remember in the form of table. You just see here. Here also you have to remember some of the number. So first here one-tailed test we'll discuss now. In a one-tailed test, the critical values of z will be like this. At 5% level means minus 1.645 to r 1.645. One-tailed means either only one side, either positive side or negative side. It means in between r will come. So even here the next at 1% level means minus 2.33 or 2.33, either negative side or positive side. Any one side you have to concentrate. Whereas in a two-tailed test means both the side you have to concentrate. At 5% level means from minus 1.96 to 1.96. So minus 2.58 and 2.58 for 1% level of significance. So this numbers you have to remember, students, here. Next, test of significance for large samples. Large samples means here n value will be greater than 30. Then only we are going to call it as a large samples. Test of significance for single proportions. This test is used to find significant difference between proportions of the sample and the population. Let x be the observed number of success in sample size n and the acceptance of success. Let the associated standard normal variate z can be denoted. Already I given the formula for this z, that is x minus mu divided by sigma. This formula you have to remember. Here mean is nothing but NP. So here NP is nothing, mu, the value of mu will be NP, and standard deviation sigma is nothing but square root of NPQ. That formula you have to remember. After substituting that, after calculating the value of Z, if the value of Z is greater than 2.58, then we can conclude that the difference is highly significant and reject the hypothesis, because the obtained value is greater than the standard value, means we are going to reject the hypothesis. Since P is the probability of success, square root of PQ by N is the standard error, then to find out the probable limits, this is the formula we are using, that is P plus or minus 2.58 square root of PQ divided by N. If they in a question, if they given P, Q and N value, means easily we can find out the probable limits with the help of this formula. These are all the theory part you have to remember here. Thank you.